All right, still in Chapter 4, Helicopter Flying Handbook, page 8 of 18, going into engines, the reciprocating engines, right after the anti-torque drive systems. Engines, reciprocating engines. Reciprocating engines, also called piston engines, are generally used in smaller helicopters. Most training helicopters use reciprocating engines because they are relatively simple and inexpensive to operate. Refer to the Pilot's Handbook of Aeronautical Knowledge for a detailed explanation of illustrations of the piston engine. Turbine engines. Turbine engines are more powerful and are used in a wide variety of helicopters. They produce a tremendous amount of power for their size, but are generally more expensive to operate. The turbine engine used in helicopter operate differently from those used in airplane applications. In most applications, the exhaust outlets simply release expended gases and do not contribute to the forward motion of the helicopter. Approximately 75% of the incoming airflow is used to cool the engine. The gas turbine engine mounted on most helicopters is made up of a compressor, combustion chamber, turbine, and accessory gearbox assembly. The compressor draws filtered air into the plenum chamber and compresses it. Common type filters are centrifugal swirl tubes where debris is ejected outward and blown overboard prior to entering the compressor, or engine barrier filters, EBFs, similar to the K&N filter element used in automotive applications. Although this design significantly reduces the ingestion of FOD, debris. It is important for the pilots to be aware of how much debris is actually being filtered. Operating in the sand, dust, or even in grassy type materials can choke an engine in just minutes. The compressed air is directed to the combustion section through discharge tubes where atomized fuel is injected into it. The fuel-air mixture is ignited and allowed to expand. This combustion gas is then forced through a series of turbine wheels, causing them to turn. These turbine wheels provide power to both the engine compressor and the accessory gearbox. Depending on model and manufacturer, the RPM range can vary from a range low of 20,000 to a range of high 51,600. Power is provided to the main rotor and tail rotor systems through the freewheeling unit, which is attached to the accessory gearbox power output gear shaft. The combustion gas is finally expelled through the exhaust outlet. The temperature of the gas is measured at different locations and is referenced differently by each manufacturer. Some common terms are inner turbine temperature, exhaust gas temperature, or turbine outlet temperature. TOT is used throughout the discussion for simplicity purposes. Turbine outlet temperature. A compressor. The compressor may consist of an axial compressor, a centrifugal compressor, or a combination of the two. An axial compressor consists of the two main elements, the rotor and the stator. The rotor consists of a number of blades fixed on a rotating spindle and resembles a fan. As the rotor turns, air is drawn inward. The stator vanes are arranged in fixed rows between the rotor blades and act as a diffuser at each stage to decrease the air velocity and increase pressure. There may be a number of rows of rotor blades and stator vanes. Each row constitutes a pressure stage, and the number of stages depends on the amount of air and pressure rise required for the particular engine. A centrifugal compressor consists of an impeller, a diffuser, and a manifold. The impeller, which is the forged disc with integral blades, rotates at a high speed to draw air in and expel it at an accelerated rate. The air then passes through the diffuser, which slows the air down. When the velocity of the air is slowed, static pressure increases, resulting in compressed high-pressure air. The high-pressure air then passes through the compressor manifold, where it is distributed to the combustion chamber via discharge tubes. If the airflow throughout the compressor is disturbed, a condition called surge or compressor stall may take effect. This phenomenon is a periodic stalling of the compressor blades. When this occurs, the pressure of the compressor is reduced, and the combustion pressure may cause reverse flow into the compressor output. As the airflow through the compressor is reduced, the air pressure then increases temporarily, correcting the condition until it occurs again. This is felt throughout the airframe as vibrations and is accompanied by power loss and an increase in turbine outlet temperature, TOT, as the fuel control adds fuel in the attempt to maintain power. This condition may be corrected by activating the bleed air system, which vents excess pressure to the atmosphere and allows a large volume of air to enter the compressor to unstall the compressor blades. The combustion chamber. Unlike a piston engine, the combustion in a turbine engine is continuous. An igniter plug serves only to ignite the fuel-air mixture when starting the engine. Once the fuel-air mixture is ignited, it continues to burn as long as the fuel-air mixture continues to be present. If there is an interruption of fuel, air, or both, combustion ceases. This is known as flame out, and the engine must be restarted to relit. Some helicopters are equipped with auto relight, which automatically activates the igniters to start combustion if the engine flames out. All right, so the turbine. The two-stage turbine section consists of a series of turbine wheels that are used to drive the compressor section and other components attached to the accessory gearbox. Both stages may consist of one or more turbine wheels. The first stage is usually referred to as the gas producer, N1 or NG, while the second stage is commonly called the power turbine, N2 or NP. The letter N is used to denote rotational speed. If the first and second stage turbines are mechanically coupled to each other, the system is said to be direct drive engine or fixed turbine. These engines share a common shaft, which means the first and second stage turbines and thus the compressor and output shafts are connected. On most turbines assemblies used in helicopters, the first stage and second stage turbines are not mechanically connected to each other. Rather, they are mounted on independent shafts, one inside the other, and can turn freely with respect to each other. This is referred to as a free turbine. I love a good free turbine. Accepting free turbines. When the engine is running, the combustion gases pass through the first stage turbine, N1, to drive the compressor and other components, and then past the independent second stage turbine, N2, which turns the power and accessory gearbox to drive the output shaft as well as other miscellaneous components. All right, accessory gearbox. The accessory gearbox of the engine houses all the necessary gears to drive the numerous components of the helicopter. Power is provided to the necessary accessory gearbox through independent shafts connected to the N1 and N2 turbine wheels. The N1 stage drives the components necessary to complete the turbine cycle, making the engine self-sustaining. Common components driven by the N1 stage are the compressor, oil pump, fuel pump, and starter generator. The N2 stage is dedicated to driving the main rotor and tail rotor drive systems and other accessories such as generators, alternators, and air conditioning. So that is page 10 of 18, but it is picture time. Let's see. All right, looks like we've got figure 415. The tail rotor drive shaft is connected to both the main transmission and the tail rotor transmission. Okay. We need this one right here, though. Figure 416. Many helicopters use a turboshaft engine to drive the main transmission and rotor system. The main difference between the turboshaft and the turbojet engine is that most of the energy produced by the expanding gases is used to drive the turbine rather than producing thrust through the expulsion of exhaust gases. All right. Air inlet. Pretty cool. Okay, we'll hold off there. That was page 10. Left off at accessory gearbox, going into transmission system in chapter 4. See ya.